In 1854, Britain entered the Crimean War. Almost immediately, reports started flooding back to London of thousands of soldiers dying in massive numbers. While cannons and muskets took their toll, the true slaughter occurred in the hospital wards, where typhus, cholera, and dysentery claimed far more lives than enemy fire. The British Secretary of War asked Florence Nightingale to organize a team of nurses and traveled to Scutari in modern-day Istanbul. When she arrived at the military hospital, she found a logistical and sanitary nightmare. Wards were built directly over leaking cesspools. There was zero ventilation. The water was contaminated with raw sewage, and soldiers were sleeping on floors crawling with rats, without even basic soap or clean linens. Nightingale realized the British Army's own medical infrastructure had become a death trap, making the hospital far deadlier than the front lines. She immediately enforced strict hand-washing protocols, flushed the sewers, and established a laundry. She also began rigorously collecting data to prove that environmental contamination was the true killer. But Nightingale faced a massive political hurdle. The ruling class, specifically Queen Victoria and Parliament, routinely ignored the dry academic tables of numbers used by statisticians at the time. If she could not bridge this communication gap and force policy changes, countless more soldiers would die from preventable infections. She understood that having life-saving data was worthless without a new method of persuasion that made politicians feel the true severity of the crisis. Working with the statistician William Farr, Nightingale invented an entirely new visual language. She called it a coxcomb, though today we know it as the polar area diagram. Standard pie charts were ill-suited for the task. Because their slices change angles to represent percentages, they fail to show a continuous seasonal timeline. Instead, she used a 360-degree circle to represent a continuous cyclical year. The circle is divided into 12 equal wedges of 30 degrees each. Each wedge represents 1 month, allowing a viewer to track how deaths swelled during the freezing winters and shifted as seasons changed. Because the 30-degree angle remains constant for every month, the death rate is represented by the total area of the wedge. This area varies strictly in proportion to the square of the radius. To show a death rate that was 4 times larger, she only had to double the radius. This created massive, blooming shapes that were impossible for a politician to ignore. This geometric framework ensured total mathematical accuracy while deliberately maximizing the visual shock value of the data. The final layer of her design was a 3-part color coding system used to instantly separate the causes of mortality.